Working with electricity is dangerous. This video is an example of what we've done. Read the disclaimer carefully before you continue.
Okay, and that's what it looks like when everything is done. Nice lead case, fireproof, fire extinguisher, and our two switch boxes or breaker boxes. One coming in, one going out. Okay, today we're going to start with the installation of the inverter. The last set of videos took you up to the point where you had this breaker box, or little DC DB, where the 24 volts comes out of the battery cabinet. So what we're going to do now is we're going to install an inverter that's going to change the 24 volt into 240 volt AC. To do that we need two main components: the inverter, obviously, this is a 24 volt 2.5 kV inverter, and then we've got a distribution box that we'll use to connect the AC that's coming from the house to the inverter. Now what we've got in here is we've got a trip switch that is to protect you if you accidentally touch a live wire. There's two separate breakers here, one for lights and one for plugs. You'll see that they're both 6 amp breakers, so the plug circuit obviously cannot take heavy duty equipment, especially inductive loads. It's got motors in it. We're going to break the rule for one of them because I am going to put my fridge on it, and that's an inductive load. The inverter, though, although it's rated at 2.5 kV, can for very short periods of times actually take a spike of up to 4 kilowatt. So that should cover the eventuality when the motor in a fridge actually switches on. And then we've got this strange little box here. This is basically a 3-pole double throw 230 volt relay. Now what I'm going to do with this is that some essential equipment that will be connected to my plug circuit, if the AC goes off in the house from the municipality, then and only then will the solar system take over. So for instance, things like my electric fence and my alarm system will run off AC mains coming from the utility provider, and only if there's no power from the utility provider will it switch over and actually draw current from the batteries. So the only real thing that I'm going to pull off this cabinet is there's going to be 3 plugs for computers in the house, and then the fridge, as I've already mentioned, and the TV. So those are the only things that's really going to be connected to this plug circuit, and then via the relay I just need to add another breaker there. We will have those circuits, that's emergency circuits, so that my alarm system and my electric fence will continue to operate even if there's no power from the utility. Now if you remember, when we started with the PV installation, I told you that I had an existing small PV installation with a 250 watt panel and 2 batteries, and for this installation I used an 800 watt inverter. Now that's fine if you only want to pull lights, but even if we use a lot of lights during the evening with the two 12-volt batteries that we've got, the batteries doesn't last through the night. So sometimes, especially if we had a cloudy day, around about 8 o'clock in the evening or 9 o'clock in the evening, we're actually sitting without light. So the big installation will prevent that from happening. So I'm not going to take the old installation out for now. It will be moved later to another part of the property where there's a flat on the property that one of my sons stays in. So what I've done is I've cleared some space next to the existing installation where we're going to actually fit the new inverter. Okay, so the inverter, you should never install that in the same box as your batteries. It's always best to install it indoors, but in a place where there's decent ventilation. Make sure that it doesn't get too warm or too hot, because the higher the load or the current that you pull from it, the hotter the inverter is going to become. But inverters don't like things like humidity and wind and rain and so forth. So we're actually going to bring the cables through the wall into the garage and install the inverter and the DV box inside the garage. Okay, so I've installed the two wires that goes through the wall into the garage where the inverter will be fitted against the wall. You can see they're quite thick, about 70 millimeters square. And the reason why the cables are so thick is because we're sitting with quite a distance from the batteries. If you think about it, the leads from the batteries to the common point to the switch to the inverter is already about 1.5 meters. So we need quite a thick conductor to make sure that we can carry a fair amount of current. Okay, I've installed the AC distribution box, switch box, close to where my alarm system is installed. So I've got a feed coming in from the inverter that's on a earth leakage switch. Then I've got two circuits connected to this relay, and basically this relay would, as long as there's battery power, feed battery power to these two switches, and if the battery power is finished it will switch back to AC mains. This relay is just reverse, so it feeds the switch. It's always on AC mains unless AC mains fails, and then it fails over to battery. So this switch I'm using for all the security systems in the house, the alarms, the electric fences, the perimeter protection and so forth. And that's one of the reasons why I installed it close to the alarm system. So these two switches at the moment not connected, so they will go into the roof, the 6 amp breaker for plugs and the 3 amp breaker for lights. I have to do some rewiring in the roof just to make sure that everything that goes onto the PV system is completely separately wired. One of the big things that you must be careful of is that the earth of AC mains, basically at street level at the transformer, is basically the common point of the transformer, but that's also the neutral. of any phase. So if you got 3 phase in your property, then neutral and earth is basically the same. The earth leakage protection that I'm using here is newer technology. In essence, it measures the current through both the neutral and the live wire, and if the current flow is not exactly the same, it will assume that there's a leakage somewhere. So with the newer devices, you actually don't need earth connection, so you can quite happily use them if you've only got live and neutral. The reason why that's important, especially if you start talking plugs, is if somebody touches a live wire, you want that to basically switch off immediately to protect the person from electric shock. They will get a little bit of a jolt, but definitely not die. So I'll do the rewiring of the lights and the plugs to the roof on another occasion and come and connect it up. At the moment, the line going to the security systems is already live. So you can see there's a plug top that's already got power. So before I pack up for the day, the only thing that I'm going to do is rewire the alarm system AC to go onto this new plug. You'll see it's a red plug. In South Africa we've got plug tops. Normally the plug top, the earth on top, is round for a South African plug top. This one is flat, so that means a normal plug top you can't plug it into there. So that means you can't plug a normal plug top into any one of these red plugs. So why that's important for me is I want to make sure that only things that I want to be on the PV system is plugged into the PV system. So I'm the custodian of the red plugs in the property. So unless I fitted a red plug to it, it will not be plugged into a plug that's connected to the PV system.